So guys, I'm trying to demonstrate if suppose the numbers are big in a problem, x and y values are big. So what can be done to solve the problem, by reducing the values? So you can solve this problem using the previous method also, which does not involve reducing the values. That also you can do because you're having calculators, but then you should be aware of this shift of origin method as well. Now look at the individual values of x and y. They are relatively big. They are not single digit. They are a bit bigger. Okay. So what we'll try to do is we'll try to reduce these values. Okay. We'll try to reduce these values and solve. And at the same time, let me just frame a question for you. Find the value of x when y is equal to 10. So let this be the question. Okay. So x depends on y. Okay. Use line x on y. X minus x bar is equal to bxy y minus y bar, equation number 1. Now x bar, y bar and bxy we need to calculate, and this is the line bxy is not the line. Bxy is the regression coefficient of line x on y. So it's the regression coefficient of the line, not the line. It is the regression coefficient of the line, not the line. Okay. So bxy is regression coefficient of x on y. Okay, now we'll try to reduce the values which are given over here in the problem. We'll make it small. So let's introduce something which is called as a. Okay, so a is assumed mean. A is nothing but assumed mean. So a is equal to bigger value, which is the bigger value over here. Bigger value is 27 plus smaller value. The smaller value is 16 upon 2. So this is equal to 43 upon 2, right? So if we solve this 43 upon 2, it's 21.5. We'll approximate this to either 21 or 22. Both values are okay. Then b. Okay, b is equal to bigger value plus smaller value upon 2 in y. The bigger value in y is I think it's 44. Okay, and the smaller value is 37 upon 2. So take the average of the bigger value and the smaller value. Okay, so 44 plus 37 will give you 81 divided by 2. That is 40.5, which is equal to, either it can be taken as 40 or 41, not a problem. So a and b values we are having in front of us. Okay, so next step will be u is equal to x minus a and v is equal to y minus b. So x minus a, 16 minus 21, and that is equal to minus 5. 18 minus 21, that is equal to minus 3. 27 minus 21, that is 6. 23 minus 21, that is 2. 17 minus 21, that is minus 4. Okay, so let u is equal to x minus a, right, and v is equal to y minus b. Just find out the total of u. So the total of u is 8 and it is gone. So this is minus 4. U is equal to minus 4. V is equal to y minus b. 39 minus 40. B is 40. So that is minus 1. Okay. Then 44 minus 40, that is 4. 37 minus 40 minus 3. 40 minus 40 is 0. 38 minus 40 minus 2. Okay. So 4 and 4 is, so the answer is minus 2. The total of v is minus 2. Okay, then we'll calculate u bar and v bar. U bar is equal to summation u upon n, summation u upon n. U is nothing but minus 4, minus 4 upon 5. V bar, summation v upon n, minus 2 upon 5. Okay, now u is equal to x minus a. Just remember this technique to calculate x bar and y bar. Okay, you can also do summation x upon n, summation y upon n, but then u is equal to x minus a. Therefore, u bar is equal to x bar minus a. Remember this. So u bar is equal to minus 4 by 5 x bar minus a. A is, we have taken a as, in the calculations we have taken a as 21. Okay, so let's take this as 21. So 21 minus 4 by 5. Okay, so x bar is equal to 21 minus 4 by 5. X bar is equal to 21 into 5 minus 4, 101 by 5. Okay, v is equal to y minus b. Therefore, v bar is equal to y bar minus b. V bar is minus 2 by 5. Y bar we don't know. B is, I suppose it is 20. We have taken it earlier as 20. Okay, let's verify that information. Yes, b is equal to 40. Sorry, b is equal to 40. Yeah. So let's take b as 40, and so y bar is equal to 40 minus 2 by 5. So y bar is equal to 40 into 5, 200 minus 2, 198 by 5. We got the value of x bar and y bar. Okay, let's go back to the previous slide, that is where we have written the equation. So x bar and y bar values we have got. X bar and y bar values you can also calculate using summation x upon n, summation y upon n. But then I have done using it using u and v. Keep it in fractions. If it is not divisible, then keep it in reduced fractions. That will help you in your calculations. Okay, to get more accurate answer. So now we are supposed to calculate bxy. Bxy is equal to covariance of xy upon standard deviation of y square. But then remember, we have converted the problem to u and v. Okay, so bxy will be converted to buv. X got converted to u and y got converted to v. So bxy is equal to buv. So that is covariance of uv upon standard deviation of v square. Equation number 1. We'll start with covariance of uv, summation u into v upon n minus u bar v bar. So summation uv. So summation is besides uv, so we need to find out u into v column. So this is 5 minus 5 into minus 1, that is 5. Minus 3 into 4, that is minus 12. This is minus 18, 0, and this is 8. So this is 13 minus 30. Okay, so the total of this is 13 minus 30. That is minus 17. Okay, so this is minus 17 upon 5 minus u bar. U bar is, I suppose it is 101 by 5 and 198 by 5. Okay, multiply the first term with 5 throughout. Okay, minus 101 into 198 by 5 into 5. Okay, so this is minus 85. 25 is the common denominator over here. So minus 85. Okay, 101 into 198. 19,998. 1,998 plus 85. That is equal to minus 20083 upon 25. That is covariance between u and v. Don't get frightened with the bigger values. You have a calculator with you, so there is no need to be frightened about this. Okay, then standard deviation of v square. So first we'll find out variance of v, right? So variance of v is equal to summation v square upon n minus v bar square, v square. So we'll calculate the column of v square. Okay, so 116,904. So this is 20 plus 10, that is 30. So this equals 30 upon 5, 30 upon 5 minus v bar. V bar is 198 upon 5 the whole square. So this is 6 minus 198 into 198 upon 198 upon 5 the whole square. We'll just square it. Okay, so just a second. 198 square 39204 upon 25. So this is 150 minus 39204 upon 25. Variance of v. Variance of v is equal to 150 minus 39204 minus 39054 upon 25. Now standard deviation of v is square root of variance of v, squaring both the sides. Standard deviation of v square is equal to variance of v. Standard deviation of v square. The variance of v is 1930, sorry, 39054 upon 25. So what we can do now is we'll just go back to bxy. So bxy, this is equation number 2, sorry. Okay, bxy is equal to buv, and both the values we have. Bxy is equal to buv. Okay, covariance value is minus 283 upon 25, and this is minus 39054 upon 25. Okay, so this is getting cancelled. So bxy is equal to 20083 upon 39054. Let us divide and see what value we are getting. So 20083 divided by 39054. It is almost 0.5142. So this is 0. Almost 0.5. Okay. So basically, guys, I'll just leave it as it is because we're not getting a proper division value over here. You can also reduce it if you want, like divide if you want. Okay, but then I'm aiming for a more accurate answer. So we'll have to put this value in equation number 1. So we have x bar, y bar, and bxy. So we'll just write down from 1, x minus x bar. X bar is let me see what is x bar. X bar is 101 upon 5, and this is 20083 39054. Y minus y bar. Y bar is 198 upon 5. Okay, so this is line x on y. Okay, now see, these numbers are very big, so that's the reason why I'm not simplifying this. You can simplify, take LCM, and just get a simplified form of the equation. Okay, but then you can leave it as it is if the numbers are way too big. Now in this, put the value of y as 10. So if you put the value of y as 10, you will get the necessary answer. Okay, so x minus 101 upon 5. So 101 upon 5, if you divide it, okay, that is 20.2. This we calculated earlier, so this is 0.51, and 10 minus 198 upon 5, 39.6. Okay, so what I'll do is I'll just multiply this 10 minus 39.6, that is minus 29.6, into 0.51 that is minus 15.096, and this minus will be plus on the right hand side. So I'll add minus 15.096 to uh, whatever value I got on the right hand side. So 20.2. Answer is, so the x value that I'm getting is around 5.104. Okay, so after solving this, x is 5.104. Okay, so that is how you can calculate the values by making use of u and v. Okay, this method is called a shift of origin. When we are subtracting or adding x and y with some values, it is called a shift of origin. Okay, so I have demonstrated one problem in which you can reduce the values by making use of a and b. Okay, so x is equal to u is equal to x minus a, y is equal to v is equal to y minus b. That way you can reduce the value of x and y and solve the problem in terms of u and v. Okay, you can refer to the through this to this particular recording and practice some problems based on this. And in the same problem, I'll give you one more thing to verify on your own. So find y when x is equal to, let's say, 50. Okay, so here y depends on x. Use line y on x, y minus y bar, byx, x minus x bar, equation number 3. Okay, now x bar y bar we have already calculated in the first part of the problem. Byx is equal to bvu. This time it won't be uv, it is bvu, because y is getting converted to v and x is getting converted to u. So this is covariance of uv upon standard deviation of u square, equation number 4. Now here also covariance of uv we have already calculated in the previous part of the problem. You just have to calculate variance of u. Okay, and you can proceed and complete this problem as self study. Some part of it I have already discussed as hint. You can take it ahead from here. Okay, yeah, thank you.